Now we talk about AC transformers. Now AC transformer consists of two coils. These are wound around a core. So you see there are two coils wound around the core. And this core is, say, an iron core. The coil connected to input alternating voltage source is called primary winding. So we have primary winding right here. So this is connected to the source of some current, and the coil connected to the load resistor is called secondary winding. So this part is connected to a load. So this part is connected to a source of current, and this is connected to the load. This is the secondary winding. So the purpose of iron core is to direct the magnetic flux from one coil to the other with minimum loss. So this iron core is just transferring the flux from this primary coil to the secondary coil. So primary coil here is in red and the secondary coil here is in blue. So if the number of turns in the primary winding is N1, so the number of turns in primary winding is N1, so you have number of turns here N1, then the voltage across the primary is V1 is equal to minus N1 times d phi b by dt. So this is the flux going through loop by loop. So phi b is the magnetic flux through each turn. So you take flux turn by turn, that is why you multiply it with minus N1. Now if all the magnetic field lines remain inside this core, the flux through each turn of the primary winding equals the flux through each turn of the secondary winding. So all this magnetic flux is in the core. So flux coming out of this primary winding is going into this secondary winding. So you also have this induced voltage in the secondary winding now. V2 will be equal to minus N2 times d phi b by dt. So the flux remains the same. So this is the same in both the cores. So you replace d phi by dt here in equation 1 and 2. You just eliminate d phi b by dt. You get V2 by V1 is equal to N2 by N1. So you can also see this. You take equation 2 and you divide it by equation 1. So this is our primary equation for a transformer. So when N2 is greater than N1, so N2 is greater than N1, the numerator is greater than the denominator on the right hand side. That would imply that V2 is greater than V1. So this is called a step up transformer. So in this transformer, the voltage going out of the transformer is more than the voltage coming into the transformer. If N2 is less than N1, so this N2 is less than N1, then V2 is less than V1. So this is a step down transformer. So this step down transformer, it takes high voltage and makes it lower voltage. So you have decreased the numerator here in terms of number of windings. Therefore, the voltage will also have to decrease. So for example, in this example, you can see that N1 is much bigger. So the red turns are much more than the blue turns. So we have this condition, N2 is less than N1. So this is example of a step down transformer. So both step up and step down transformers are used in power transmission. So at the power station, you first step up the voltage and make it extremely high voltage, and close to the source of consumption, that is close to the households, you use a step down transformer and reduce this high voltage. So this is all about there is to know about transformers.